Hi, my name is Bruno Silva. I'm a student at University of Aveiro, and today I will talk about Easybddi. With Easybddi, we can connect a great variety of data sources, such as relational or NoSQL databases. Easybddi recovers data organizations at each data source and automatically proposes a global schema, which is an abstract representation of the distributed data organization, which can be fine-tuned by users. Users can then create one or more star schemas based on global entities and use drag and drop to query such star schemas. Easybddi handles query generation and distributed execution and presents query results according to the star schema perceived by the user. Let's take a brief look at Easybddi's architecture. Trino is used as a distributed query engine. It maps data source organization into a relational model and supports SQL querying on a great diversity of data sources. Easybddi uses schema matching, integration, and mapping techniques to create a global schema. We have models that, specialized models that are responsible to create configuration files for Trino, star schemas, maintain metadata such as schema information and global schema to local schema mappings, and create analytical queries that will be executed by Trino in the data sources. Users connect the data source and configure the schemas using a wizard. To create analytical queries, users may use drag and drop over the high-level global abstraction, thus allowing for non-expert users to easily interact with the system and query distributed data. For the demonstration at EDBT, we prepared two case studies. The first uses real data on the production and consumption of energy by photovoltaic panels in Sydney. We'll use CSV files and two relational databases as data sources. The second case study is based on the SSB Plus benchmark, and we will configure cubes for batch OLAP and streaming OLAP. In this session, I will mostly focus on the first case study, but both of them will be available for you to use in the interactive demo session. This is Easybddi's main menu. In Easybddi, we use projects, and each project has one or more data sources, a single global schema, and several star schemas. After a project is created, users open it, choose a star schema, and submit queries. So I will show you a very brief walkthrough of a configuration process to create a new project. This configuration is done in a step-by-step wizard-like interface. So first, we need to identify the data sources. Required connection information depends on the data source that we select. You can see here that we already have two CSV files and two relational databases. Then Easybddi gathers the relational abstraction of data organization at each site, and then we can select schemas or tables that we would like to use. Now, when I press the next button, Easybddi will use schema, matching, and integration techniques over the selected tables and will automatically create a global schema abstraction. Now, you can see that this interface now shows us the proposed global schema in the left tree and the relational abstraction for the local schemas. Now, local schemas are organized by servers. So if we open this server, it is a MySQL database and it has two tables here. We can even see its columns and information about those columns. We also have here the two CSV files that we have added, and if we open the CSV file, we can see its fields, and here they are mapped as a relational table. Now, when we open, let's inspect the global schema. If you can see that if we expand the nodes in a column in the global table of a global table, we can see the correspondences to the local schema. So, for example, this column is corresponding to this column in the local schema. Each column in the global schema has a node that indicates to what column in the local schema it is corresponding to. Note here that Easybddi is identifying this as a simple mapping. So what this means is that this table, this global table, has only one correspondence to one local table in the local schema. We also have two other types of mapping. We have horizontal mapping, in which one global table is corresponding to more than one local tables, and those local tables are horizontally partitioned. But we also have vertical mapping, where the local tables that correspond to one global table are vertically partitioned. Now, to create correspondences, we can either drag a column in the local schema and drop it to the column in the global schema that we would like to create a correspondence, or we can also drag an entire table in the local schema, drop it here in the global schema, and Easybddi will create a table, a global table with the same structure and with the correspondences to the table that we have just dragged. Another useful feature of Easybddi is that we can define new abstractions on local data organization using SQL code. For example, the original CSV files have a structure that it is not suitable for us for this use case. So I used this feature that Easybddi has and added an SQL query that rearranges, that it has a set, this SQL query has a set of operations that basically creates pivots and unpivots operations, which rearranges some rows to be seen as columns and some columns to be seen as rows. So this view that we have created, and we can see here, exists only within Easybddi and does not affect the original files. We can also, so this is a structure that is much more suitable for us, and we can do this type of operation with Easybddi. We can even drag, so I did this, created this view for each of the two for each of the two CSV files, and I also created a global table here, whose correspondences to the local schema are these views that I have just created. Now let's talk about the star schemas. To create a new star schema, we need to give it a name. We need to select the facts table, to select the dimensions and the measures in the facts table, and this will conclude the configuration process. Now that we have a project configured, we can start creating queries. So this is a screen in which users will create queries. On the left, we have the star schema. We have the measures, the dimensions, and the attributes. The idea here is to drag elements from the star schema to areas here, to one of these areas here. So each of these areas represents a different operation that will be created for the query that we are constructing here. So if I drag this attribute here, results of this attribute will be presented as rows. If I drag this attribute here, results will be presented as columns. We can sort the results. We can also create filters. So see June, we can see customer IDs less than 3. We can also filter in here this the year. So I want to see the years between 2010 and 2012. We can also add aggregations. So for example, if I drag this measure here and drop it here, this measure stands for energy consumption. Now we can select an aggregate function. I'll select sum, and now we just execute the query. So what happens here now is that Easybddi is taking my input and it is converting it into an SQL query, which will then be given to Trino. Trino is now executing my query over the data sources that we have connected, and the results of the query will be here presented in the format of the star schema that we are seeing here. So here we have the results. More advanced users may also enter some pieces of code to manually specify manual aggregations. We can do the same with filters instead of just aggregations only. So I can write here more filters. This is for users who would prefer this approach over using just the user interface. This concludes this brief introduction of Easybddi. I hope you enjoyed this demo, and please join us in the interactive demo session, in which we will have the opportunity to see a more in-depth walkthrough of Easybddi and prepared use cases. Thank you for watching.